In this module, we will take a deeper look at registering services. You'll learn about extension methods on the iService collection and when to use them. We'll address situations where it may not be readily apparent how you can register services for some advanced situations you may face when developing applications. For each of those situations, we'll review the options available when using the built-in Microsoft container and start to explore where we run into its feature limitations. You'll also learn how to improve the organization of service registration code within more complex applications. Before we dive into the various registration scenarios, it's worth a brief interlude to touch on the concept of service descriptors. Service descriptors contain information about services that have been registered with the dependency injection container. They are used internally by both the iService collection and the iService provider. The service descriptor class includes several properties which hold details about registered services. This includes the service type for the registered service, which is typically going to be the interface, details about the implementation type, which will be the type that's constructed when the service is resolved, and information about the lifetime of the service. You rarely need to work directly with service descriptors, since they're typically created for us by the various extension methods on the iService collection. Even though we weren't aware of them, we've been creating them already using the add_transient, add_scoped, and add_singleton methods. As I'll demonstrate later in this module, there are some advanced scenarios where we will need to begin to work more directly with service descriptors. Once built, the service provider and its related internal components use a collection of service descriptors for your application, created from those that you register with the iService collection. Earlier, we registered the iWeather Forecaster using a transient lifetime. Now that we've learned more about lifetimes, we can decide on the most appropriate lifetime for this service. Both of the current implementations do not have any dependencies nor any mutable state, so we can opt to register this as a singleton service. So far, we've been using the generic add_singleton extension method to register services. This convenient shortcut registers a singleton service descriptor behind the scenes. I'll paste in 4 examples that each create an equivalent service descriptor for this service. This first option creates a new instance of a service descriptor using its constructor, accepting 3 arguments. The first is the type for the service, the iWeather Forecaster interface in this case. The second is the implementation type, the Amazing Weather Forecaster class. The final argument specifies a singleton lifetime using the service lifetime enum. The second variation uses a static factory method on the service descriptor class called describe. This accepts the same 3 arguments as the constructor. Since we always need to specify a lifetime for service descriptors, static methods exist for each lifetime to simplify their creation. This example uses the singleton static factory method, which only requires the service type and the implementation type as arguments. A generic version of this also exists, which is cleaner since we no longer need to use the type of expression. Once a service descriptor instance is defined, we can add it to the service collection directly using the add method. I want to reiterate that in most situations, you should use the extension methods on the iService collection and avoid creating service descriptors manually. We'll learn about some of the scenarios where we do have to work with service descriptors later in this module. I'll comment out these lines of code, but leave them here should you want to explore them later. We've already seen how to register services with the dependency injection container. What do you think would happen if we were to create more than one registration for the same service type? We'll put that question to the test in this demo and find out. We'll understand the difference in behavior between the add and try-add extension methods on the iService collection. Returning to the code, the iWeather Forecaster has been registered with an implementation using the Amazing Weather Forecaster class. I'll create a second registration using the iWeather Forecaster interface as the service type, but this time we'll use the Random Weather Forecaster as the implementation. Let's add a breakpoint in the constructor of the page model for the index page. If we run the application, we can inspect the implementation type that gets injected by the dependency injection container. Once the breakpoint is hit, I'll open the locals window to see the local variables. The dependency injected into the index model constructor is the random weather forecaster. In situations like this one, where there are multiple registrations for the same service type, the last registration wins. Because our second registration used the random weather forecaster for its implementation type, that is the one that's been resolved at runtime. You may recall me saying that the order of registration for services is generally not important. Well, this scenario is one of the exceptions to that statement, where the order of the calls used to register services can become more significant. As applications grow and require many service registrations, accidents can happen, and duplicate registrations can creep into our code. We can avoid such inadvertent errors by using other extension methods on the iService collection. Let's change these registrations to use the try_add_singleton method. Only the method needs to be changed here, the arguments remain the same. To use the try_add extension methods, a using directive is required for Microsoft.extensions.dependencyinjection.extensions. The Visual Studio tooling can help add that for us. After this small change, if we run the application, we hit the breakpoint once again. This time, the injected type is the amazing weather forecaster, the first service we registered. And this is a subtle but crucial difference in behavior. The try_add methods only register a service when there is no registration already defined for that service type. The second call to try_add_singleton attempted to register a second implementation for iWeatherForecaster, but this registration was skipped because a registration for that service type already existed. We can update our other service registrations in the tennis booking application to prefer the try_add based methods. Preferring try_add is particularly convenient when developing more complex applications that contain many service registrations. It allows us to express our intent more clearly when registering services and helps avoid accidentally replacing previously registered services. Unless you explicitly intend to register something, ignoring a prior registration, it's often safest to prefer the try_add methods. When calling add_singleton twice, using the same interface as the service type, we saw that the second and last implementation was the one that got resolved. You may now be wondering what happened to that first registration in that scenario. A reasonable assumption would be that perhaps the second registration entirely replaced the first one, but that's not the case. Let's take another look at the code and see what's happening. I'll revert to the code without using the try_add_singleton registrations, so we now have two registrations for the iWeatherForecaster service type, both using the add_singleton method. I'll add a breakpoint here on the line, adding the second registration. After running the application, when the breakpoint is hit, we can inspect the state of the iService collection using the locals window. If we expand the services variable that points to the iService collection, we can see that it contains 82 items at this stage of the program's execution. We can explore the current state of the iService collection by opening the results view on the iEnumerable. The last item at index 81 is the registration for the iWeatherForecaster service type, with Amazing Weather Forecaster as its implementation type. If I step over this line by pressing F10, the second registration occurs, and we can inspect the state of the service collection. Now the last entry is at index 82 and is a registration for iWeatherForecaster. This service descriptor defines Random Weather Forecaster as its implementation type. Calling an add method such as add_singleton multiple times for the same interface results in multiple entries in the service collection. When a service depending on iWeather Forecaster is created, the dependency must be resolved from the container. The last registration into the container is assumed to be the preferred choice, and therefore an instance of its implementation type will be resolved. Having studied the behavior of the add and try-add methods, a scenario remains. What if we really do want to replace prior registrations? In this demo, you'll learn how to replace a service registration. I'll also demonstrate how to remove service registrations from the iService collection. It's possible to update the service registration here to replace the existing registration for the iWeather Forecaster service type. The iService collection includes a replace method that we can use to achieve this. The replace method does not support any generic overloads, and this is one of the situations where we must provide a service descriptor as an argument. We'll use the singleton static method on the service descriptor to define a descriptor for the iWeather Forecaster service type with the implementation type as random weather forecaster. The replace method will look for the first service registration for the iWeather Forecaster service type, and if it finds one, remove it. The new service descriptor will then be added to the iService collection, and its specified implementation type will be used when resolving the iWeather Forecaster service type. If I add a breakpoint and run the code, we can inspect the items in the service collection just as we did in the last demo. This time, we're back to 82 items in the collection, and only the random weather forecaster service descriptor exists because it's entirely replaced the previous registration. It's important to note that the replace option only supports removing the first registration of a service type within a collection. Removing all previous service registrations for a service type is also possible. Suppose we undo our last change back to the point where we have two implementations registered for the iWeather Forecaster service type. The remove all method supports a single generic argument which takes the service type that we want to remove. We'll remove all iWeather Forecaster implementations by providing that interface as the generic argument. After rerunning the application, when we hit the breakpoint and inspect the iService collection, we see that there are now only 81 service descriptors in the collection. Expanding the results view, we see that both registrations against iWeather Forecaster are no longer present and they've been completely removed. The last service registration in the collection at this point of execution is for the iConfiguration service type. Both techniques demonstrated here are fairly rare, but they may prove helpful if you want to provide your own implementations for framework or third-party services. In that case, it may be reasonable to remove previous service registrations before you register your own implementations. Before we move on, I'll switch back to preferring the try-add singleton extension methods for these registrations, and I'll comment out this redundant line.